The deck of your machine is that portion that actually contacts your material and makes the separation. To maintain an optimum separation, you should check the deck frequently. Clean and repair as necessary. Dust will build up on the underside of the deck. This causes a restriction of airflow, reducing the separation efficiency, and eventually the deck will plug or blind completely. Your deck should be blown down with compressed air as necessary. Do this while the machine is running material. Dust that is lodged on the underside of the deck will be loosened by the reverse air blast. Blinding can also be caused by improper overcover selection. An overcover should be sized so that the smallest particle in your product doesn't stick in or pass through the wire mesh. Because the overcover mesh is in direct contact with your product, it is subject to abrasive wear. Inspect your deck for wear by brushing your hand over the mesh and check for smoothness. Normally, when the wires of the deck overcover are worn halfway through, it is time to repair the deck. Before you start a rebuild, always inspect the deck thoroughly. Look at the underside of the deck and inspect each rib for cracks. Inspect the undercover. Replace ribs or undercover as necessary. Most tools used for a deck rebuild are common. Not all these are necessary to complete the job, but if available, they will make the job easier. First, remove the metal trim around the deck, including the rock trap, side gates, wood blocks, and deck aprons along the high side and discharge end of the deck. Next, remove the horizontal metal pieces called riffles running across the top surface. It is preferable to replace all the riffles at one time. Even though some may look okay, the leading edge will wear thin and will crack when removed. When removing the overcover, do not damage the undercover. Place the deck on sawhorses with adequate light underneath. Always stretch the screen tightly. A pair of vice grips with large jaws works well. There are 3 sets of belts and sheaves in your HiCap and Master Gravity Separator. They are the main drive belts or fan belts, the idler belt from the fan shaft to the vari-speed unit, and the eccentric belt from the vari-speed to the eccentric shaft. Your new machine's belts should be checked after initial startup and again during the first week's running, as new belts will stretch as they are broken in. To check belt tension, turn off the machine and lock out power. Then apply pressure to the outside of the belt midway between the 2 sheaves. The belt should deflect approximately 1/2 inch. The eccentric belt from the vari-speed to the eccentric shaft has a shaft running through it. The shaft must be removed or slid back to install a new belt. For this reason, a spare belt is installed around the shaft on all new HiCap and Master Gravities. Note that proper belt tension is maintained on the eccentric belt by the spring action in the vari-speed sheave. There is no manual adjustment. If the eccentric belt slips, it is an indication that the vari-speed sheave is defective. The vari-speed sheave changes the ratio between driving and driven pulleys, so the eccentric speed can be altered. It is located in the base of the machine at the opposite end from the motor. It is normal for these sheaves to wear and should be expected. Most customers get 2 or 3 years of use before it is necessary to replace, depending on usage and environment. The life of the vari-speed can be extended if it is operated through its entire range at least once daily. Replacement of the vari-speed is relatively simple. With the machine running, turn the vari-speed adjustment toward the fastest eccentric speed. Turn off the machine and lock out the power. Roll the eccentric belt off the pulleys. Loosen the set screws and slip the vari-speed off the shaft. Slip the new vari-speed sheave onto the shaft and tighten the set screws. Install the eccentric belt. Turn on the machine and set to the required speed. The complete vari-speed assembly can be replaced with either a DC or AC motor with electronic motor controls. Call the factory representative for details. We supply top-quality U.S.-made sealed bearings that provide a positive lock to the shaft. All bearings are installed using Loctite compound and are fully tested for rumble and overheating. The most common problem on new equipment is shaft-to-bearing contact failure. A bearing set screw comes loose and allows the bearing to turn on the shaft, wearing a groove in the shaft. Check all bearing set screws after your machine has run 8 to 10 hours, and again after 150 hours of service. Even sealed bearings require occasional greasing. Don't over-grease bearings. Only one shot of grease given every 1,000 to 1,500 hours. It is always a good idea to thoroughly check over the bearing set screw, bearing housing, and the adjoining shaft while greasing. Outside the air chest, remove the springboard and slide the eccentric bearing off the old shaft. Inside the air chest, remove the air chest dividers, baffles, and baffle feet. The pillow block bearings can now be unbolted and the old shaft removed. Clean and check shaft for damage. Also, check to be sure the shaft is straight. Check and replace bearings, sheaves, and belts as necessary. Wipe the new shaft down with a cleaner. Make sure bearings slide smoothly down the shaft. Slide all 4 bearings onto the shaft. Slide the drive pulley and belts onto the shaft. Place the shaft with bearings into air chest and bolt down to the eccentric angles. After eccentric shaft and bearings are bolted down, check to be sure that the shaft will still slide back and forth in the bearings. If the shaft will not slide, realign the bearings until the shaft moves freely. Center the shaft in the air chest with equal amount of shaft sticking out each end. Slide about 2 inches and apply Loctite bearing compound on shaft. Slide the shaft back into position. Secure extra eccentric belt to the air chest with Velcro or wire mounting. Reinstall the key in the keyway and position the eccentric pulley 1/8 of an inch from eccentric bearing and tighten. Reinstall dividers, air baffles with baffle feet, eccentric bearing, and springboard. After replacing the eccentric shaft, the machine needs to be timed to shake properly. See eccentric rod adjustment in troubleshooting. Remove the old shaft by driving out the end or by cutting between the fan housings. After the old shaft has been removed, take all of the blower wheels out of the fan housing. Clean and inspect them, check for cracks, missing pieces, or anything else that may cause an imbalance. Clean all lubricants and debris from all surfaces directly related to the fan shaft, bearings, blower wheel, hubs. With everything removed, inspect the PN B13 bearing support angles for deformities. Straighten or replace as necessary. The surfaces must be flat before replacement. The B13 angles on each end of the machine must be parallel with the top and bottom of the machine. The top of the B13 support angle is 12 7/8 inches above the floor panel of the box. This is for the end B13 angles only. The other support angles must be aligned perfectly. Use a known straight edge, such as a length of square tubing, or stretch a string through the length of the machine. Don't measure from these angles to the floor to determine linear alignment. This will not be accurate enough. Once the angles are aligned, insert the new shaft through the blower wheels and bearings in the same sequence used to remove the shaft. It is imperative that all debris and contaminants are removed from the shaft, bearings, and fan hubs. If you are using the old bearings, make certain they are free of all Loctite and will slide freely the entire length of the shaft. The shaft should slide freely into the machine. Do not beat or hammer. This will cause brinelling in the bearing, resulting in premature bearing failure. After the shaft is pushed through and bearings are located on support angles, center the shaft in the end blower housing or the center line of the B13 angle. Do this at both ends. Tighten each end bearing, being careful to maintain the shaft in the center on both ends. Once you have checked the shaft for center, tighten the rest of the fan shaft bearing mounting bolts. Make sure tightening the mounting bolts does not distort the linear alignment of the shaft. Do not over-tighten, as this can break the pillow block bearing housing. Push the shaft through so that it is an inch past the final set point, which is 5 inches out of the bearing at the motor end. Liberally apply Loctite RC 609 or equivalent to the shaft directly in front of the bearing. Quickly do all the bearings, then push the shaft back in until 4 inches of shaft is exposed. Then tighten down the bearing locking collars. Try to turn the inner bearing race. Replace all sheaves and belts.